Hello again. This is Scott from Healthy Golf. It's March 3rd, 2020. Revisiting the cartoscope project. And I'm sorry we're a few months behind since Sophie had a breakthrough in how to retrieve some good imagery for coastal Louisiana. And going back to Sophie's notes, and my notes, but Sophie created this document, created some reference files, some KMLs to open, to look at, and some slides. You know, there's a lot of miscommunications that we did resolve in that last meeting. And then I made a bunch of notes in January and asked Naomi for a grid. You know, I was thinking, and I was saying a 4,000 foot image because, and it's a dumb term because it just meant in Google Earth, when you go to 4,000, it says 4,000 feet here. That is actually more like 500 meters on a side. This image, this way, the long way, is 500 meters. So I said, let's try a 1,500 meter partition of an area of interest and you know, make photographs like this across West Bank, Jefferson, and Plaquemines Parish. So I made an area of interest to create a grid within that I wanted Naomi to work on. She hasn't been able to do that. And you know, Sophie had a link for us she found an ArcGIS copy of the colored infrared photograph of coastal Louisiana from 2016 that had this API call, so you could bring up all the images. And Matt figured out that it wasn't in lat long, the URL was related to UM15. And that's what we discussed. We also discussed the previous method from USGS, creating big, like special slides of special characterizations. Basically, they had training characterizations, and I have those worksheets if we want to actually go through and do what they probably did. Like there's these characterization worksheets you can fill out. But instead, I have made slides instead. So I guess put a button in that. Let's think about, do you want me to actually write out characterization worksheets? It's old school, but it's what you would do if you worked for the government so that others could check your work and replicate your work, right? It's how they would QA, QC your characterization and your delineation resulting from the characterization. We're doing more of a raster delineation in cartoscope, you know, just picking out imagery and using the characterization, which we have as slides and as a video instead. So we found that some of the AOI falls within UTM-16, some of the stuff in lower Plaquemines. And this is interesting because some of the converters want to go and automatically convert you to UTM-16, which is annoying because then you know, it generates an easting that's incorrect, which messes up the auto-generated code that I did. But here are some sites that do conversions. Those weren't doing pretty well, but I did get pretty far in QGIS. I had the area of interest. I had the LOSCO land-water boundary. That's kind of the map behind you that you see. And I made a whole bunch of layers, which you can see in this menu. Just generating different grids, right? Here's kind of my different notes on converting it. You know, for a photograph that's 15,000 meters on the side, it's this many degrees, which is an important number to input into QGIS when you're using geographic coordinate system. And it gives you 42 photographs. Obviously, that's not enough. The more specific we can make the photographs, the better. I was originally thinking 500 meters, which would be a tremendous amount. But I think I've backed off that. The 3,000 generated 957 photos. And if we clip the east bank of the river out of there, as well as, you know, there's a lot that are just open Gulf, you know, we can get 677 photos. And even still, some of those are water. Right. So and then I did a 1500 partition, clipped it to 26, and then clipped it to the West Bank to give us 1,390 photographs, and that's this scale. That's what, you know, the photographs are taken from this grid. That's a great scale, I think, for characterizing. It's kind of a bear. It's a lot more photographs than the normal cartoscope. So I think instead of 500 meter and 1,500 meter, I think we should go with 1,500 and 3,000. So these are just notes about my conversions. I made slides and I made a video and I sent it to Dr. Coker. I did the conversion. Matt started it, and sorry, Matt, I just went right past you and did it using this federal government site that does conversions, right? I did the multi-point conversion. Oh, I should say, once you create the grid in QGIS, you can save the shapefile, open the DBF, and it gives you the Xmin, Xmax, Ymin, Ymax, right? And you can mess around with that and do a conversion. And I was trying to fix it to UTM-15 like this. For a multi-point, you know, we are doing geodetic lat long. That's what it's in. And we choose a particular file. It has to be in a very certain format with only 3 columns and no headers. That's pretty easy to make. So I may have messed up when we look at the future. I may have messed up for the 3,000 meter layer, but I did do the conversions. And then I made spreadsheets here. For different intensities of partition. I gave the photographs a particular ID so that we know, you know, this is the West Bank 1390 selection. I have a shapefile that's called that. Of the 1390, there is an ID, and these don't all add up because I think these are part of that original 3,000 odd photographs. And then they're just selected from that. They were clipped, right? But they are unique, even though they're not sequential. So this is a totally unique number for the photograph that we get when we take the geographic coordinates generated by the GIS. I just cut and paste to put these in a better order. So I've graded them out because it's just so that they cut and paste in the appropriate orientation for the conversion software. Then the conversion spits it out and you get something like this. It also has a field of which UTM-15 we selected, but it actually gives you that in a field what this refers to, And you can get a min easting, northing, max easting, max northing. And that is the format for the API call, both the URL and the HTML versions. So you can take that sequence and easily concatenate it and make something to cut and paste into the HTML version of the API call for the photo. And then I also have just a couple of boxes. I really only need one or two. I don't need these 3 columns, but it's just me messing around, concatenating, making different URLs, so then when we click on something, it generates this and gives you the section of the DOQQ 2016 color infrared photograph, which would be your data input, right? So this thing here, that's the thing you can cut and paste from that one column into there, hit return, and it'll generate, a different web page. And the second URL just generates the image. So if you only want the image, that's the second URL. I guess we can look at that. Right. Bing. So there it is. According to my characterization, that looks like, maybe, is that a canal? Maybe, but mostly this is coastal erosion. And then remember, we also have a project. We're saying, is this mostly land or water? This is mostly water. I think that's pretty obvious from the photo. But then again, I'm the one who dreamt this up. So I've went through a few of them, right? And I guess I should put coastal erosion. I even named that kind of its own thing, Scott's notes for this particular one, the 1500 West Bank 1390. Coastal erosion. Now we relate it, and that's a correct answer. Maybe. I also went through, and because we had problems with the second one, I have just some checks. So here, I wanted to see, does the max easting always larger than the min easting, right? If you're in UTM, that should be true. And the same thing with the northing, and it turns out these are all true. These all work. It's pretty awesome. They all work. So all of this column is 1,390 images we could put into a cartoscope. And I'll leave it to you guys to download them or figure out if there's a better way to be doing this that's not as dreary. There's one that's all water, right? And I think the further south you go, I think these are now geographically ordered. Further south you get, the more coastal you get. So here we get coastal erosion, on the barrier. This is a new barrier island, and it's mostly water, right? And the more coastal you get, the more of those you're going to have. Erosion, new barrier island. That's kind of cool. And the further up you get, this is a really good one. This is climate change to me. We have some natural bayou features. We have some other natural bay features, but we don't have our pipeline or oil and gas scars. We have disintegration patterns. So I'm going to go through and just put in 1077 climate. Yay. All right, so let's look at the 3000 level grid. So again, we have a lot fewer images with this, but when we did the conversion for the max, I kind of did 2 conversions. I did a min conversion and then a max conversion. 2 pairs. Yeah. This is 29, this is -90, this is 29, lower, -90 and less. And for some of the more easterly ones, like this one's -89, closer to London or Greenwich, the conversion put us in UTM 16. And what we're finding is that for those where, and that failed the east check, right? Because we've now skipped to the next UTM zone and the max easting is now lower than the min easting. There's got to be something simple I'm missing. This fails, right? Or it just gets confused and gives you like the whole data set, right? It's giving you the maximum east, right? But then the minimum east is so far west that it's a huge image. Yeah, so that's why it gives you a huge honking image. Some of these. So that needs to be fixed, and there's probably a conversion. I'm just too tired to think of it. But for some of the ones that are true, that seem to work, you have this, boom. And this is, you're going to get more images that have multiple causes in the same image at this resolution. Here we have an oil and gas field, and it's like a whole field. And, we have a drainage canal, we have a natural bayou. This is still oil and gas, right? It's mostly land, and the land that's lost is pretty coherent and mostly oil and gas. So if you said, though, a combination of oil and gas and shipping, because you knew a little something, and actually there's a drainage canal. This is mostly a drainage canal, not really a nav canal, although it's used for navigation. That wouldn't be wrong either. So the trouble with this resolution, it's great. It's 387 images. Maybe it could be useful. Like, look at this. This would be oil and gas. It's heavily disintegrated and also has small canals. But, if someone said this was climate change, that would be a pretty good answer, because it's just, it's even got some erosion patterns in here. It's a little bit of everything. You can make a note, oil and gas and climate. This coastal erosion. It still has the disintegration patterns in it. So, if you said climate, but this is mostly coastal erosion. Okay. And then for this false thing, again, it's really this max easting that's messed up. So I think this video is kind of long. That's where I am with the cartoscope project. I mean, I feel like I could do these 300 myself, which is another interesting thing, because 387 I feel like I could do myself. 13, or we could give it to Naomi, see what she does. Would be a good task. 1390. I feel like it's more discrete and it's more precise, and it's going to give us more of a true estimate of the grid where we should be searching for climate change impacts. And that is tremendously helpful, because once we get that, we can do that photo comparison from 1990 to 2016, right? That's my vision for when we do that photo series. I don't need a 1990 photo color infrared to move forward with cartoscope. But that's it. That's the work to date. I need to figure out why some of these aren't working, or there's probably a very simple conversion into UTM 16. I mean, to convert this from UTM 16 to UTM 15. And so I've made a column to have a formula to convert it. but I've got to do some other things this week. So that's all I can work on this week. So thanks for listening to this video. Go to the note sheet and click through the spreadsheets, click through the images, see how fun they are, and let me know if you have any questions. Okay, this is Scott signing off.